Hi students, have a nice day. In this section we are going to discuss about the naming of cyclic compounds and nomenclature of organic compounds which contains functional group. In the last section we discussed about the general rules for naming alkanes, alkene and alkynes. Okay. A cyclic compound means the carbon chain, the hydrocarbon chain form a ring. So cyclic compound is naming, cyclo is prefixing the word root, or the prefix cyclo is used before the word root. Okay. Then the other rules are similar. Number the carbon chain from one point to the another point. If there is any substituents, the substituents will get the lowest possible number. More substituents are present in the compound. We follow the lowest sum rule. Then identical position, we must consider the alphabetical order. Like that. Okay, the general rules are following here also, but we use cyclo as a prefix before the word root or the parent hydrocarbon chain. Let's discuss some examples. The first example, naming of cyclo compounds. Cyclo is used as a prefix. Cyclo is used as a prefix. For example, CH2, CH2, CH2. It is a cyclic compound. 3 carbon atoms are present. This is a bond line structure. This is condensed formula of cyclopropane. So 3 carbon atom, that's why the name of the compound is cyclo. Okay, cyclo is prefixed. 3 carbon atom, that's why prop. And all the bonds are single bonds. Single bond between the carbon atom, so ANE. What is the name of the compound? Cyclopropane. Then another one is CH2, 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 CH2. Or the bond line structure is, you draw a square. Okay, draw a square. It is cyclobutane. Cyclobutane. Why? Cyclic compound, that's why we use cyclo as a prefix. Then 4 carbon atoms, so but. Then a single bond between the carbon atom. That's why we use the suffix ane, saturated compounds. Then usually it is easy to represent the bond line structure. Another is, what is the name of the compound? It is cyclopentane. Cyclopentane. Are clear? 5 carbon atoms in the ring. Then another one is cyclohexane. Cyclohexane. Similarly, cycloheptane. Cyclooctane. Okay. Seven carbon atom in the ring. 1, 2, 3, 4, 5, 6, 7. This is cycloheptane. Okay, cycloheptane. Similarly, cyclooctane. Okay, how many carbon atoms? You just count 1, 2, 3, 4, 5, 6, 7, 8. The compound is cyclooctane. Okay, cyclooctane. Are you clear? Yes. So this is the naming of cyclic compounds. Then we discuss the naming of cyclic compounds which contains substituents. Okay, so we move to the cyclo compounds which contains substituents. Okay, cyclopropane contains substituents. As we know that terminals are CH3. Terminals are CH3. Or the condensed formula of the compound is CH2, CH2, CH, CH3. This is the bond line structure. This is condensed formula. So only one substituents. So that's why the name of the compound is methyl cyclopropane. Methyl cyclopropane. Substituents are secondary prefixes. Cyclo is a primary prefix. Cyclo is just before the word root. Then substituents are secondary prefix. Okay. You remember the formula for a compound: secondary prefix, primary prefix, word root, primary suffix, secondary suffix. Okay, the formula is given to you in the previous section. So you remember that any substituents you must prefixes. If cyclo compound is there, we use cyclo as a primary prefix. The other substituents are considered as a secondary prefixes. So secondary prefix first, then a primary prefix, word root, then suffix. Here there is no functional group, so there is no secondary suffix. Secondary suffix we will discuss later. Then another compound. This is another compound. Cyclopentane. 1, 2, 3, 4, 5. Cyclopentane. And CH2, CH3. Okay, terminals are CH3, bends are carbon atom, and the valency of that carbon is satisfied by hydrogen or other atoms. If other atom comes, we should represent. So here is no other atoms, only hydrogen. So number the chain. 1, 2, 3, 4, 5. Only one substituent, that's why there is no need for mention the position. It is ethyl. Okay, ethyl group. Ethyl group is attached to cyclopentane. Cyclopentane. As two substituents are there, you should mention the position. Okay, let's discuss one example. Okay, in this case, so two substituents are there. Okay, two substituents are there. Then you should number 1, 2, 3, 4, 5, 6. Or in the reverse order 1, 2. Identical position. And both are same substituents. So 1, 2 is enough. In the reverse order, so from here 1, 2, 3, 4, 5, 6. The numbering is same. And what is the name of this compound? If two or more substituents present in the cyclic compound, you should mention the position. Only one substituent or functional group, there is no need to mention the position because it comes in the first carbon atom. So here it is 1, 2 dimethyl. Okay, first and second position contains methyl group. So 1,2 dimethyl cyclic compound. So the primary prefix is cyclo and the 6 carbon atom in the ring, that's why hexane. Okay, hexane. If two different groups comes, you should follow the alphabetic numbering. Okay, methyl group, this is methyl group and this is ethyl group. Okay, we just number 1, 2, 3, 4, 5, 6. And in the reverse order, 1, 2, okay, I use another pen to distinguish the numbering. Okay, starting from 1, 2, 3, 4, 5, 6. Okay. In both the case, the substituents are in the first and second carbon atom. That means identical position. What we'll do when identical position of substituents comes? We must follow the numbering in the alphabetical order. Okay, if identical position of substituents in the organic molecule, we follow the alphabetical order numbering. So methyl, ethyl, which comes in alphabetic order, ethyl. So the name or the number order is correct, this one. Okay, then 1 ethyl, first position ethyl. 2 methyl, cyclohexane. Okay, identical position comes, we should follow the alphabetical numbering. Okay, then another one. This is propyl group, CH2, CH2, CH3. Okay, propyl group. The numbering is 1, 2, 3, 4, 5, 6. And in the reverse order, 1, 2, 3. 1, 3 is there. Okay, which numbering is correct? Propyl group, P. Okay, start from P. Methyl group, starting from M. So in the alphabetic order, methyl group get the priority. So this numbering is correct. Then writing in the alphabetical order also. Substituents are written in the alphabetical order. So the name of this molecule, 1 methyl. Okay, 1 methyl. 3 propyl. In the third carbon atom, propyl group. 3 propyl cyclohexane. Are you clear? Yes. Then we use one more substituents. Okay, another we can discuss one more substituents. Here the maximum number of substituents are 2. So then we discuss the molecule which contains one more substituents. Okay, let's take an example. 2 methyl group in the first carbon atom or any other carbon atom and 1 ethyl group. Okay, so numbering is 1, 2, 3, 4, 5, 6. Another 1, 2, 3, 4, 5, 6. Here the substituents are not in the identical position because lowest sum rule must be applied before the identical position. Okay, let's take the lowest sum rule. This carbon is 1. So one carbon atom or first carbon contains 2 substituents and the second carbon contains 1 substituent. What is the maximum sum? It is 4. As earlier lowest sum rule, nowadays it is lock and rule. Then by considering this numbering, the number is given in the black pen. Our first carbon atom contains only 1 substituent. So 1. Then second carbon atom 2 substituents. So 2 comma 2. What is the sum of this set? It is 5. Are you clear? So while numbering this, the lowest sum is 4. In this pattern, the sum is 5. So 4 is the lowest sum. That's why the numbering is given by red pen is correct one. What is the name? The substituents are written in the alphabetical order. That must be important. So ethyl and 2 methyl groups. So ethyl comes before. So this numbering is wrong. Okay, that we have to remove. This is correct one. When you write, you use pencils. And the correct one you retain, the wrong numbering is you just erase. Okay, that's a good method. After practicing, you can easily understand that this numbering is correct, that is wrong. When you initially, when you study this numbering, you use pencil. And after finding substituent position, all these things, the correct numbering you retain, the wrong should be removed. Okay, so 2 ethyl. Listing must be in the alphabetic order. That's very important. 2 ethyl, 1 comma 1, dimethyl hexane. Dimethyl, sorry, cyclohexane. Sorry, dimethyl cyclohexane. Are you clear? Not, this is not 1 ethyl, 2 comma 2, dimethyl cyclohexane. Okay, some students numbering is given in the alphabetic order. No. Okay, first you consider the lowest sum rule. Then only you can follow the identical position. Okay, or you think about it. The carbon with the maximum substituents will get the lowest possible number. Okay, here this carbon have 2 substitution. This second carbon atom having 1 substituents. So the carbon with the more substitution will get the lowest possible number. Okay, that's the rule. Yes, that's about the substitution in the cyclic compounds. Another is a double bond or triple bond present in the cyclic compound. What is the name of this compound? What is the name of this compound? Cyclic compound, 6 carbon atom and a double bond between the 2 carbon atom. So ENE is the suffix. So the name is cyclohexene. Cyclohexene. Then if any substituent is there, for example, double bond, 1 methyl group. The numbering is given to the, priority is given to the double bonds. Okay, alkene. So 1, 2, 3, 4, 5, 6. It is 3 methyl cyclohexene. Okay, 3 methyl cyclohexene. Here you remember that the double bond is in between the lowest possible number. Double bond in between the lowest possible number. And if 2 double bonds are there, the position of double bond you should mention. Another example. Here two double bonds are there. Okay, so starting from here or from there, 1, 2, 3, 4, 5, 6. Or you can start 1, 2, 3, 4. Same way, same number. Okay, differ by this numbering, first and third position. By this numbering, first and third position. So identical position. Now substituents. So this is cyclohexane. Okay, two double bonds are there. The position is mentioned 1, 3. First carbon atom double bond, third carbon atom double bond, diene. Okay, cyclohex or sometimes hexa, cyclohexa 1, 3 diene. Okay, yes. Then when triple bond comes, what we have to do? When triple bond comes in, the suffix in is used. Cyclohexyl. Cyclohexyl. Okay, so that's about the naming of cyclic compounds. Okay, next we discuss the organic compounds having functional group. Okay, what are functional group? You know that a heteroatom or group of atoms which decides the chemical as well as physical properties are called a functional group. Okay, so when functional group is present in the organic molecule, we use secondary suffixes. We denote the number of carbon atom in the parent chain. Prefixes are substituents. Primary suffix means whether the molecule is saturated or not. Secondary suffix means the functional group which is present in the organic molecule. Okay? Yes. So what are the different functional groups? Alcohol, aldehydes, ketones, amines, carboxylic acid, acid chlorides, amides, esters, sulfonic acid, nitriles, that means cyanide compounds, then halogen groups, nitro group, etc. These are functional groups. Okay, so let's discuss some example how the molecule is named. Okay, so first example is by taking alcohol as an functional group. Alcohol, OH. Okay, some example we'll discuss. Alcohols, the functional group is OH group. The heteroatom is oxygen. OH group is the functional group. Heteroatom is oxygen. CH3OH. Okay, what is the name of this molecule? One carbon atom, so meth. Single bond present in the carbon atom, so ANE. Okay, the primary suffix is ANE. Secondary suffix alcohol, the secondary suffix is ol. Okay, yes, so the name is methanol. Methanol. E of the primary suffix is dropped when the secondary suffix started with the vowels. So O, A-E-I-O-U. Okay, E, the secondary suffix is started with the A-E-I-O-U. E of the primary suffix should be removed or dropped. Okay, so that's why methanol. Another alcohol is CH3CH2OH. Two carbon atom and alcohol, single bond between the carbon atom, so ethanol. Ethanol. Then another is CH3, CH2, CH2OH. From here, we mention the position, because in this case, if the OH group is present in the left hand side carbon atom, this also 1, 2. Okay, 1, 2. If the OH in this carbon atom, 1, 2. The position is similar. That's why we didn't make the position. But when 3 carbon atom comes, we mention the position. This is propan 1 all. Okay, propane 1, 2, 3. Propane. So propane, first position alcohol group. E is dropped. Why? The secondary suffix is started with the vowels. Then it has an isomer. That's why we must mention the position. Okay, CH3, CH, OH, CH3. The position of OH group is changed. So that is why it is propan 2 all. Propan 2 all. Its trivial name or common name. You know that what is trivial name. Trivial name is derived from the source or the properties of that molecule. So this is N-propyl alcohol. N-propyl alcohol. That's its trivial name or common name. What about this one? An isomer. So it is isopropyl alcohol. Okay, you mainly study the IUPAC naming system. So this is the naming of alcohols. When 2 alcohol groups comes, for example, CH2OH, CH2OH, 2 carbon atom, so F, and single bond between the carbon atom, ANE. First and second carbon atom contains alcohol. That's why we use diol. And E should be retained. Why? The secondary suffix is started with a consonant. If it is started with a vowel, we drop the E of the alkane or alkene or alkyne. But if the secondary suffix is started with a consonant, the E should be retained. That's why ethane 1, 2 diol. Okay, the first and second position alcohol group. Then another example, CH2OH, CH2, CHOH, CH2OH. From any direction, the numbering is 1, 2, 3, similar. 1, 2, 3. Okay, the functional group having 1, 2 and a third position. 3 carbon atoms, so prop. 3 carbon atom, prop. Single one between the carbon atom, so A and E, propane. Okay, then the number of functional group is 3, so triol. T, started with a T. Mention the position 1, 2, 3, triol. Okay, propane 1, 2, 3, triol. That's the IUPAC name. What is its common name? I think you heard about glycerol or glycerin. This is glycerol. The common name of the propane 1, 2, 3 is glycerol. Okay, next we consider the aldehyde. CHO. Aldehyde. Aldehyde. The secondary suffix is al. When aldehyde comes, we use al. Okay, the first molecule is CHO. It is methanol. Methanol, methane, al, methanol. 1 carbon atom, that's why methanol. Its common name is formaldehyde. Okay, the common name of the molecule is formaldehyde. Another is CH3CHO. 2 carbon atom and the functional group is aldehyde. Okay, this carbon also number in the chain. Aldehyde carbon also number in the chain. So 2 carbon atom, that's why ethanol. Okay, ethanol. The common name is acetaldehyde. Acetaldehyde. Then another is CH3, CH2, CH2, CHO. 1, 2, 3, 4. Butanol. IUPAC name is butanol. And the common name is butylaldehyde. Butylaldehyde. Okay, so this is the naming of some compounds having functional group. Okay, in the next section we will discuss the compounds having polyfunctional group or more than one functional group. Okay, one more example we can use COOH group, carboxylic acid group. Carboxylic acid, a common functional group, carboxylic acid. 2 carbon atoms, so ethane. COOH group, the secondary suffix is OE group. So O, starting with a vowel. So ethanoic acid. Similarly, propanoic acid, butanoic acid, like that. And more example we will discuss in the next section. Thank you.